Alright, this outstanding chemistry class of secondary school and even A-level classes. Welcome back to my YouTube channel. My name is Arabi Kazim. I'm your host on this channel always. You can lean on me when it comes to chemistry, that's no problem. So let's quickly do a final revision for NECO Chemistry Practical 2026. Comment A1, 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 A1. Comment A1, A1. Now, the acid we are looking at tomorrow is going to be H2SO4, which is 2.7 cm3 to be dissolved in 1000 cm3 of water. And the base is sodium hydroxide of 4.0 gram. This aspect actually is a secret sad for chemistry teacher. As a student, you don't actually need this aspect. Okay, chemistry teacher, you know how to prepare your calculated total value. Using the direction factor, we are going to be having C1 V1 and C test CD C2 V2. So our C1 is 18.0, which is from the stock solution of H2SO4, while 2.7 is what we have been given in the yellow paper of tetraethyl acid, while we are actually looking for our concentration of COM2, while our volume 2 is 1000 cm3. So when you do that calculation, you're going to have our expected or our suspected or our guess concentration of acid, which is 0.0486 mole per dmq of H2SO4. So the molar mass for sodium hydroxide is 40, which is gram per mole. So when you use all of that to calculate with the equation, you can see that we're going to be having our calculated titer value to be 25.75 cm3. Calculated titer value. So it might be higher, but it might be lower. Just make sure it's within the range of the specification for standard marking for NECO, which is plus or minus 0.2 for your student. Okay, so we'll be looking at about 4 questions, likely question, prediction questions might likely come out for the exam. So let's look at now one question. One question titration is we'll be using 25.7 cm3 all throughout this calculation. Look at the one question. It says A is a solution of H2SO4, while B is sodium hydroxide. Okay, now sodium hydroxide is 1 gram per 250. That means if you are going to use this value, you are going to be converting it to what? To gram per dmq. Right? So our table of value is 25.7 cm3. So the examiner will actually pick 2 out of the 3 value or 2 values. So me I actually make use of 2 values. Okay, you can see the 2 values that I use. The difference between them is 0.00. Yours can be plus or minus 0.1, can be plus or minus 0.2. NECO actually accepts 0.2, but it's better to be on the safer side. Plus or minus 0, plus or minus 0.0 is okay. You can see the difference between 25.70 25.70 is 0. So all throughout this calculation, I'll be using this value as my volume of acid, which is 25.7 cm3. Alright, let's look at the first calculation. Calculate concentration of B in gram per dm. Remember, we're giving in gram, which is 1 gram in 250. So we are going to convert it to gram per dmq. So you remember that one dmq equals to 1000 cmq. Okay, this cmq is the volumetric flux 1000 that you use to dilute if you are to prepare it in the laboratory. So when you do that conversion, you're going to get your answer to be 4 gram per dmq. Now, what is the concentration of B in mole per dmq? You're going to be using a simple formula, but before that, you're going to calculate your molar mass. Your molar mass is sodium is 23, oxygen is 16, while hydrogen is 1. That's 40 gram per mole. So using this formula, conc mole per dmq equals to conc gram per dmq over molar mass. That's 4 gram divided by 40 will give us 0.100 mole per day. Remember, it's always those three significant figures. If you are working in mole per day, please take note because I can be able to get your full mark. Question number 3 says, calculate the concentration of A in mole per day. In this case, you can quickly use Kaval. You can use Kaval now. That's CAVA over CVPB equals to VA plus VB. So from our balanced chemical equation, we can discover that our ratio of acid to base is 1. You can see this is 1 ratio 2. And that's what I'm going to be using in my calculation, 1 ratio 2. Can you see? Okay, I like students presenting this chronologically because examiner, they are lot mark. This in the exam is 1 mark. If you have correct substitution, is another 1 mark. If you can make sense of your formula, another 1 mark. And your final answer is also 1 mark. Okay, this is always to 3 significant figure. Did you get that? And the next question is, let's calculate the number of hydrogen ion in 1 dm³ of A. Remember, our A is H2SO4. So when you ionize it, you're going to have 2H plus SO4 2 minus. Okay, what is the number of hydrogen? So you're going to multiply 2 hydrogen, that's the 2 mole of H, multiplied by 0.048, which give us 0.097 mole per dm³. Right, calculating the numbers now. Now give us calculating the number now. Now give us number of moles equals to number of ions over Avogadro's constant. So if we do that, our number of ions will multiply by our number of moles. Did you get that? So our number of moles will be this, all right, multiplied by 6.02, and that final answer give us what 6.02. The final answer give us 5.6 times 10 to the power 22. So that's question number 1. Let's check question number 2. A is 0.0486 mole per day of H2SO4. YB is 3 gram in 500 cm³ of impure sodium hydroxide. When you hear impure, it definitely shows that they are coming up with calculation of impurity or purity. Okay, so let's just see what the question look like. I told you I'm going to be using the same table of value, so we don't need to go through all of that again. You can see there. All right, let's move forward. Now the first question says calculate the concentration of B. You can see B in mole per dm³. And when you go back to our B sodium hydroxide, 1 gram in 500 sodium hydroxide. So we cannot use conc in mole per dm³ because we can't gram per dm³ per molar mass. So what you can always use is our Kava. So substituting the value correctly, we're going to have our CB to be what 0.100 mole per dm³, which is 3 significant figure. So let's calculate conc of B in gram per dm³ as requested by the question. Of course, your molar mass, you should know how to do that now. Make sure when you're calculating molar mass, your correct unit is gram per mole to score. Okay, so conc mole per dm³ is equals to conc gram per dm³ over molar mass. The molar mass is 40. All you need to do is to cross multiply. That's 0.1 times 40 will give you 4.00 gram per dm³. Your gram per dm³ can be in 2 significant figures. You will not be penalized for that. All right, hope you are taking notes. Now, can you see what I said? Now we have to calculate percentage impurity. But remember, we are giving an impure 3 gram in 500. So you are going to be converting into what? To gram per dm³. So when you do that, you have 6 gram per dm³. This is our what? Impurity. These are impure. So if you are calculating the mass of impurity now, or percentage impurity, is going to be mass of impure minus pure over mass of impure times 100. Our mass of impure is 6. Our mass of pure is 4. You can see there. That's what you experiment in the lab. 4 gram. So when you do all of that, we're going to have 33.33% as our impurity. Alright. So getting purity, you can simply say 100 minus 33.3%, which will give us 0.67%. Or you can use this formula that says mass of pure over mass of impure times 100, which is 4 over 6 times what? Times 100, which give us the same answer. Another question that say what is the mass of impurity? Mass of impurity will be the mass of impure minus pure. So if you have mass of impurity, you have to have 6 minus 4 will give us 2. 2 is our mass of impurity. I see the questions are very, 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 very cheap. Chemistry is the most simplest subject that I've ever made. Please. Let's look at question number 3. Question number 3. Question number 3 says A is 0.04856 mole per day equal H2O4. YB is 1 gram of XOH per 250. When you see a question like this, discover that this X, they will ask you to look for this X. Okay, they already ask you to look for this X. So following the same route, let's look at the question quickly. No time to waste. Don't waste your time tomorrow. Just write your question, answer your question. Write your A, get your A sharp. Conversion of B in gram per day. So we are converting 1 gram in 250 to gram per day. That gives us 4 gram. By now, you should know how to do this. Then you go to kava, then you convert to mole per DMQ. You have your final answer of 0.01 of CB. Remember of CB. Now, what's the molar mass of CB? Remember, I told you are giving XOH. You are calculating X. So we are using the formula called gram per day over molar mass. So our gram is 4, while our mole per day is 0.1. So our molar mass is what? Is 40 grams. So you equate this, you equate the XOH to 40. So that will be X plus 16 plus 1 equals to what? 40. That's X is equal to 40 minus 17, which equals 23. You can be asked to suggest what X will look like. Your X will be what? Sodium. How do you know that is sodium? So sodium weight is what? Is 23. You understand? So last question, which is question number 4. Pay attention to this last question. This last question is always a twist. Okay? Okay? A is 0.0486 mole per day of dibasic acid, and B is 4 gram of NaOH. Now we are not giving acid. Specifically, you don't know the acid, but of course you know the base to the sodium hydroxide. So you cannot form any equation. Please take note, you can't form any equation. You cannot form any equation in this context. So let's look at the twist around this question. Now look at it. The number of mole of acid in the average item. It means our mole per DMQ is what? What we are using N is equal to CV over 1000. Over 1000. So your N is your N is the number of mole you are looking for, while your C is conc in mole per DMQ is 0.0486, while your V is 25.7. Okay, divided by 1000. So your moles will be what? Will be 0.00125 moles of A. Alright? Why? That's for acid. A serves as acid. Let's calculate the number of moles of base now in the volume pipetted, which is 25 cm3. So, of course, we are going to calculate our mole because we are not giving mole. So, but we are giving 4 gram. So, 4 gram divided by 4 give us 0.0100 mole per DMQ. This is our CB now. Okay, we are going to be using it to calculate 0.01 0.100 times 25 divided by 1000 will give us 0.0025 moles of B. These is our moles of B. So now say now, before we suggest what acid could be, you can actually calculate the mole ratio of acid to base. Our mole of acid is 0.0125. You can see there. While our mole of base is 0.0250. Now, how do you get the mole of acid to base? Just divide both sides by the smallest, which is the smallest 0.125. Okay, dividing 0.0125 by 0.01, we have 1. Divide 0.00250 divided by 0.00125, we have 2. So the mole ratio of acid to base 1:2. You can see that it's making more sense now. Now, if you are asked now to suggest what an acid, because you assume that the acid is not known, but it has been told that it's a dibasic acid. That means the basis of that acid will definitely be two. So, of course, our base is NaOH. So, let's suggest a mineral acid. Let's suggest H2SO4. So, when you suggest H2SO4, when you balance your chemical reaction, you're going to be having Na2SO4 plus what? Plus H2O. So, when you balance the reaction, you're going to see that you're going to still have 1:2. Okay, this is your acid and this is your base. If you choose another amino acid, let's say for instance like HCl, you will not get the same thing. And HCl is not dibasic. So take note of all this revision question. It's a final revision question which I assure you 100% that you will not regret coming across this channel. I wish you best of luck tomorrow. Congratulations to all of you. All right, Neco. Bye for now. Thumbs up.